Good day, Sir Ogalesco, and today we will be presenting our object-oriented programming Prelim project developed in response to the provided wildlife sanctuary case problem. The scenario involves a privately owned wildlife sanctuary managed by a Filipino-Chinese zoologist who needs a system to organize and monitor the animals under his care as the sanctuary continues to grow. Managing this information manually becomes challenging because each animal undergoes changes throughout its life cycle that affect both its health rating and conservation value. A key constraint of the case problem is that an animal's conservation value is not fixed. Instead, it must be computed based on predefined conditions and updated only through controlled adjustments. The system must also be able to retain historical records for animals that are no longer active in the sanctuary, ensuring that life cycle information is preserved even after an animal is transferred or released. So in addition to tracking individual animals, the system is required to generate summarized information about the sanctuary, such as computing the total conservation value of animals currently under care. All records and operation must be implemented using an array list of objects and designed according to object-oriented principle as specified in the project requirements. And to meet these requirements in a clear and organized way, the application was structured using a design inspired by the model view controller pattern, where the main class handles user interaction and application flow. The sanctuary class manages the collection of animals, and at the core of the system is the animal class, which represents each individual animal in the sanctuary. With that context in mind, the next presenter will explain the animal class and its role in the system. That will be all. Thank you.
So, hello, I'm Ice, and I'm gonna talk about the development process of the project, specifically on how OOP is structured in the program. So, the project was built using a structured top-down approach. So, that approach ensures a logical development and, of course, separation of concerns, which is a core concept in OOP. So we're gonna start with the object definition. So obviously that is the animal in this case, which we have an animal class for. So in this class, obviously we're gonna identify all the necessary attributes, which is the ID, the species, whether it's endangered or not, its health. And this will be implemented as private. So this ensures encapsulation, which established a foundation for data integrity. So next, how are we gonna manage those objects, the animals? We're gonna have the sanctuary class for that. So this is a data management abstraction. So the sanctuary class manages the collection of those objects of the animal. So this abstracted the data storage details. Specifically, it uses a array list, which lists the animals being recorded. The objects will go into the sanctuary, and this is the class where it stores and processes those objects. So, as I said, this class manages the collection using an array list, which is away from the user interface, which we'll be talking about in the main class, so that the UI wouldn't necessarily need to know how the animals are being stored or processed. Going back to the animal class, this is where we're gonna integrate core business logic. So in the animal class, for example, if we're gonna implement some business rules such as calculating its base value, the animal itself has its own base value. So we're gonna find that method here in the animal class since it's talking about a specific attribute of that object. Another thing is if we're gonna apply adjustments, towards those attributes of the animal, of the object. Another thing is we also have an array list here located in the animal class. So that array list stores records of those adjustments, of those attributes, so that we will have an audit trail of the object of the animal. So that would be useful, especially if we're gonna have a summary that will be reflected in the or processed in the sanctuary class. So lastly, we're gonna have the main class, which will contain the menu in which the user will interact with. So the menu will be in a do while loop so that the user would have a continuous experience with the menu until they chose to. Another thing in the main class is helper methods. So these methods help the program whether or not the user chooses a specific task, and then that method will help the program forward those processes into the animal class and sanctuary class. For example, if we're gonna register an animal, of course, it needs to interact with those two classes, and that helper method will help finish that. Also, it also goes the same in different events that would happen here in the sanctuary and animal class. So, this class, the main class, implements a robust UI that has input validation and exception handling, making the application more user-friendly, more stable, and wouldn't crash as much if the user has unintentional inputs. So this progression ensured that the low-level data structures were solid before building the high-level user interface around them. So we start from the animal class to the sanctuary where those objects are being stored, and then into the UI where the user will interact with the application. So that's most of how the development was thought about using a top-down approach, and of course applying OOP structure to the program.
Hi, hello everyone, online greetings. My name is Joshua and I'm going to talk a lot about the animal class of our program. Now moving on, now let's look at the data model, the animal class. Our attribute design directly addresses the rubric's requirement that all attributes are correctly defined, identified, clearly named, and appropriate data types are used. I've enforced encapsulation by making all fields private, or the programmer used an encapsulation by making all the fields private, so that the core attributes of or the model will be encapsulated, such as animal ID, health rating, and precise numerical input, which is actually essential for the weighted factor in the value calculation, conservation value, history. This is an array list, and yeah, I think that's about it. And action we have here is the constructor and the calculate base value. As you can see in the constructor, we not only set the initial values, but we also immediately calculate the base conservation value. The private calculate base value method is the logical implementation of the business rule. The base conservation value starts at either 100 or 50 points based on the endangered status, and it is then weighted with a 0.5 bonus for every unit of its health rating, right? For the core business, I created a private, or the programmer created a private helper method called the apply adjustment. This method is single, logically entry point for the changing conservation value and updating the history list. By centralizing this logic, we ensure that the history log remains completely immutable and creates a reliable audit trail for every object, fully supporting the required functionality to track historical records, such as the public methods like apply breeding success. It is simply to define the score changes and the reason while the private helper method handles the internal control group. And for the entire class, I think that's about it. Thank you so much for listening, and I'll see you on the next class.
Greetings, Mr. Ogalasco. My name is ARISCON Cedric, and I'll be discussing about the sanctuary class. So yeah, the sanctuary class, we have a list of animals, privated of course, because we don't really want anyone directly manipulating our list. And then we have our methods over here, which is publicly accessible by our other classes. So we have the register animal, which pretty much register takes an animal object as its argument and then directly adds it into our list of animals. So there are no checks here. We don't have checks because those are intended behavior for our main class. And we had to find animal by ID, which pretty much gets an animal by by ID. And yeah, it's not case sensitive. And we have the compute total conservation value, which is of course only for active animals within the sanctuary, because deceased or transferred animals aren't exactly something that should be computed in the total conservation value. And then we have the display all animals, wherein all animals regardless of state are actually printed or displayed of their information. Display archived animal history, wherein those animals that are inactive are considered to be archived. So yeah, those that are inactive already are being printed of their history. And then we have the check if sanctuary is empty, which pretty much checks if our internal list is empty. And lastly, they are pretty much the same actually, but for readability's sake, it checks if an active animals exist, and the other one, if it's inactive, then of course it's archived in our system. So check if archived animals exist. They just differ on how they return values. So yeah, that's pretty much it.
Hi, I am MATURAN and I'm here to explain the main class in this group project. So first, we will import the Java packages, which is import java.util input mismatch exception. It allows the program to catch the errors when the users enter the wrong data type, such as entering the letters when number is expected, and without this, the program would crash immediately when valid input is entered. So next is the scanner, which is it accepts the user input from the keyboard, since our program is a menu driven and interactive. So scanner is so essential in this group project. So now here we just declared our class, which is the main class. It serves as the entry point of the program and does not store the animals itself. Instead, it controls the flow of execution and delegates data handling to the sanctuary class. So here in the main method, this is where the program starts executing, which is the public static void main. So Java always begins running a program from this method. So here we just initialize the scanner, which is our variable is sc. So that's the what we're going to call later. Next is the sanctuary, which is the object, which is our object. It is the central data manager of the system. All animals, archive records, and computations are stored and processed inside the sanctuary object. So here, int choice is equals to -1. This variable stores the user's menu selection. It is initialized to -1, so the menu loop starts properly. So here, we did the do while in our menu. So here in the do, we use do while, so the menu will always appears at least once, even before any choice is entered. Then the next one is this is the try block. The try block protects the menu from crashing when invalid input occurs, especially when reading integers. So here dito sa menu natin, merong choices na 1, 2, 8, and 0. So basically dito na pumapasok yung error handling na kapag yung user ay nag-enter ng maling input. So here, this is our menu display, which is the first one will greet you the title of this project, which is the Wild Drop Sanctuary, and these are the choices na pwede mong mapindot, or ito yung kailangan mong i-input na number to enter the menu. So here in the 1 is the registered animal, and 2 is breeding success, and 3 international recognition, 4 a medical failure, and 5 archive animal, 6 display all animals, 7 display archive history, and 8 total conservation value, and 0 is the exit. So here, after this, the menu will greet you the choose option, which is we will going to read the numerical choice by using the scanner, which is the variable sc.nextend, because it is the data type of it, which is integer. Then the next slide afterward clears the buffer to prevent input issues when switching between numbers and strings. So here after that, we have the switch statement, which is the choice, switch choice. The switch statement determines what action the system will perform based on the user's menu selection. Kumbaga, ayun, tinatawag niya lang din yung sa scanner, yung sa reading user choice. Next is yung sa case 1 natin. So here in our case 1, instead of putting all registration logic inside main, we delegate it to separate a method. This keeps the main method clean, readable, and organized, which follows a good programming practice. So pina-practice namin yun para maging good yung program and yung code namin. So here in the cases 2 to 5, which is the events and archiving. So before applying any event, we check the sanctuary that check if active animals exist. So yun yung nag-check, which is the method. This prevents the system from applying events when no active animals exist, ensuring logical correctness. If animal exists, we call apply event sc and sanctuary event type, which is the parameter, the arguments. The type parameter tells the method which event to apply, making the method reusable and efficient. Next one is the case 6, so the display all animals. We first check if the sanctuary is empty. Using the sanctuary.check if sanctuary is empty method. This avoids displaying empty data and improves user's experience. So if animals exist, we call the sanctuary display all animals. So the sanctuary class handles the actual display logic. So that's for the other class. Next is the case 7, which is the display archive history. Before displaying archive animals, we ensure they exist. So tinatawag lang ulit dito yung method na check if archive animal exist. This ensures archive history is only shown when relevant. So next is the case 8, which is the total conservation value. So if animal exists, we call the compute total conservation method, which is in the other class. This calculates the combined conservation value of all animals, demonstrating how main triggers computation while sanctuary handle the calculations. Next is the case 0, which is yung exit. So this allows the users to terminate the program. So here in the default case, this handles unexpected inputs that are outside the menu range, like yung sinabi ko kanina, which is dito na pumapasok yung error handling. So dito sa catch, which is the input mismatch exception error, this catches invalid inputs such as letters when numbers are expected, like I said earlier in the when we put the Java packages, when we input the input mismatch exception. So it ensures the program that does not crash and continues running smoothly. So here in the loop condition, the menu keeps looping until the user chooses 0. So here we did the while and choice not equals to 0. So after nag-0 siya, doon na mag-end yung loop. So here we have actually a method in this main class, which is the register animal method. So this method handles animal registration logic. So here it collects animal data, it validates input, it prevents duplicate IDs, ensures valid species names, valid yes or no inputs, restrict health ratings between 0 to 100, creates an animal object, and sends it to sanctuary. So this separation ensures main controls flow while sanctuary manages data. So why nga ba nagkaroon ng method here in the main class? So just to put it simple, it's so much accurate to put this method here in the main, so we can just easily analyze and see the exact program of what it's gonna do here in our main class. So here it's just an error handling. Actually, it's just an error handling in this part, which is if it's gonna prevent the duplicate IDs, it ensures na kapag nag-input yung users ng exact ID dun sa existing ID, hindi na siya gagana, and it will just loop until the users enter another ID para ma-accept ito ng program. It actually validates the yes or no inputs also, because here in the menu, we have the thing when you register the animals, you have a choice if it's endangered or not. So the only choice here are yes or no. So it validates that input. If hindi yun yung lumabas, it will not accept that. So it restricts then dun yung mga health ratings between 0 to 100. Yan. So here in the next in apply event method, so this method naman searches for the animal by ID, ensures the animal exists, prevents applying actions to archive animals, applies the correct event based on the type, breeding success, international recognition, medical failure, and archiving. So this design avoids code duplication and keeps logical centralized. So to summarize here, the main class acts the controller of the program. It handles user input and validation, delegates responsibilities to sanctuary and animal, and it ensures the system is robust, organized, and user-friendly. So the structure follows object-oriented principles, specifically separations of concerns, making the system easier to maintain and extend. So this is the ending of my presentation, and once again, I am Kim M. MATURAN, and this is the presentation of the main class.